Myself, Narkis Begum, Assistant Professor in EC Department in NPRCET. I am going to take one topic from Signals and System. Shall we start? Okay. So basically in Signals and System, you have to know about what is signal and what are all the types of the signal and what is system and what is the example of system. So these has to be discussed very deeply. First, what is signal? A signal is a one-dimensional signal or multi-dimensional signal. So it carries some information. It is known as a signal. Signal is a function of one or more variable that convey the information on the nature of the physical phenomena. It is known as the signal. Example of the signal is A of t, I of t, x of t, that is heartbeat, blood pressure, temperature, vibration, and then images, videos. So all are the example of the signals. And what are all the dimensions in signal is one dimensional, two dimensional or multi-dimensional signal. What is one dimensional signal? The signal which vary the individual variable means, that is single variable means, that is a one dimensional signal. Function depends on the single variable is one dimensional signal. Example of the one dimensional signal is a speech signal. So what is multidimensional signal? Which function depends on two or more variable. So example of the multidimensional signal is image signal. Next, what is system? So system which process the input signal and process it and produce the output. So which is known as the system? A entity or operator that manipulates one or more signal to accomplish a function, thereby yielding a new signal. A system which processes the input signal and produces the output signal. It may be the continuous time system or it may be the discrete time signal. Discrete time system. What is continuous time system? A system which processes the input in continuous time and produces the output in continuous time means it is a continuous time system. And what is the discrete time system? A system which processes the input in terms of discrete and produce the output in terms of discrete, which is known as the discrete time system. And what is the common example of discrete time system is system is communication system. We can say that communication system is example of the system. And automatic speaker recognition system and aircraft landing system, these are the example of the system. And basically we have to know the two things, what is continuous time signal and what is discrete time signals. So CT for continuous time signal and DT for discrete time signal. And what is CT signal? CT for continuous time. Okay, what is continuous time? See the images. It consists of two images. First one is it represents in terms of time and amplitude. The amplitude will be continuously with respect to time. Yes, it is. The amplitude, it may be continuously changing with respect to time means it is a continuous time signal. And what is discrete time signal? They see the graph, see the images in second figure, which is the amplitude will be a change at every instant of time. So it is known as a discrete time signal. There is no continuation in that. Not continuously varying. It is varying, but at the different instant of time. It is a discrete time signal. Right. Okay. Next, what is even signal and what is odd signal? What is the even signal? So even means the time x of minus t is equal to x of t. Why it is we represented in terms of t and n means t means continuous time signal and n means discrete time signal. So in continuous time signal it represents the complete the requirement of x of minus t is equal to x of t. For discrete time signal, it satisfies the condition of x of minus n is equal to x of n. So if this condition is satisfied, the signal is known as the even signal. And what is odd signal? Odd signal means the signal should satisfy the condition of x of minus t equal to minus x of t and x of minus n is equal to minus x of n, minus into x of n. So if the signal is satisfy this condition means the signal is known as the odd type of signal. And always remember that T for continuous time and N for discrete time. And from that we have to separate the whole signal into two types. One is even part of the signal, another one is odd part of the signal. That is, x of t is represented by means of two component, even component plus odd component. X of t is equal to x e of t plus x o of t. So e for even part and o for odd part. And what about in x of minus t? So x of minus t equal to even part of the signal minus odd part of the signal, x e of t minus x o of t, where from this equation we have to calculate the even part of the signal and odd part of the signal. What is the even part of the signal? X e of t equal to 1 by 2 times of the x of t plus x of minus t. And what is the odd part of the signal? X o of t equal to 1 by 2 x of t minus x of minus t, right? Okay, what is the third type is periodic and non-periodic signal. So when the signal is known as the periodic signal and when the signal is known as the non-periodic signal. So we have to see in two signals also. First is a continuous time signal, second one is the discrete time signal. So what is the conditions to be satisfied for the continuous time signal and what is the condition to be satisfied for the discrete time signal? In continuous time signal, x of t that is equal to x of t plus t means it is a periodic signal. In discrete time signal, x of n is equal to x of n plus n means it is a periodic signal. So what it says that every time capital T it should be added with the original signal x of t, we should get the again the x of t value. That means it is a periodic signal. X of t equal to x of t plus t. Okay, and what is t? T may be fundamental period. Okay, from the fundamental period we have to calculate the fundamental frequency, that is f naught equal to 1 by t naught. So from this relation we have to calculate the fundamental frequency. So in the frequency it's represented in terms of hertz or cycles per second. And what is the angular frequency? So angular frequency calculated from this omega naught equal to 2 pi divided by t naught. So where we got the t naught value? T naught for fundamental frequency. And again the discrete time signal, from this we have to calculate the f naught value and omega value. Okay. What is the fourth type of the signal is deterministic signal and random signal. So what is deterministic signal? The signal may be represented in terms of equations. It is known as the deterministic signal. That is no uncertainty with respect to its value at any time. That means it completely specified by means of the equations. Example of the deterministic signal is y of t is equal to sin t, y of t equal to cos t, and y of t equal to x of t, y of t is equal to t into x of t. So these are all the example of the deterministic signal. So it completely specified by means of the representation. Right. What is a random signal? So random means it is unpredictable. The value should not be predicted. That means it should not be represented by means of the equation. That is random signal. That is uncertain before it occur. Example of the random signal is thermal noise. So it should not be predicted. Right. Right. And what is the next one is energy and power signal. What is energy and what is power signal and where it is calculated? So from the formula we have to calculate the energy and power value. How to calculate the energy value? Energy E equal to integral of minus infinity to plus infinity x squared of t into dt. And what is power value? Power it represented by P, that is equal to limit t tends to infinity 1 by 2t integral of minus t2 plus t x squared of t into dt. So from this relation we have to calculate the energy value and power value of the continuous time signal. And what is the energy and power of the discrete time signal? How to calculate the discrete time signal energy and power? So energy equal to summation of minus infinity to plus infinity x squared of n. Now how to calculate the power value? Power is limit n tends to infinity 1 divided by 2n plus 1 summation of n is equal to minus n to plus n x squared of n. So from this relation we have to calculate the energy and power of discrete time signal. And when the signal is said to be the energy signal, the energy value should lies between 0 to infinity. And when the signal is said to be the power signal, the power value should be the finite value. That means it should be 0 to infinity. Right. So next we have to seeing the basic operations of the signal for continuous time signal, for discrete time signal. So what are all the basic operations in that? Amplitude scaling, addition operations, multiplication operations, differentiation operations, integration operations, time scaling, time reversal, time shifting, and then combination. So these are all the operations, basic operations on continuous time signals. What is addition operation? It is represented as y of t equal to x1 of t plus x2 of t. So we have the two signal. One is x1 of t and another one is x2 of t. So to calculate the addition, we have to add these two signal. That is y of t is equal to x1 of t plus x2 of t. What is multiplication operation? It is represented by y of t, that is equal to x1 of t into x2 of t. So taking the product of these two signal, we are getting the multiplication output. And what is differentiation? Differentiation is already is represented by d by dt. So y of t is equal to d by dt of x of t. So you are having the x of t value, take the differentiation of x of t, you are getting the differentiation output y of t. And how to find out the integration? Normal. Y of t is equal to integral of minus infinity to tau x of tau into t tau. So these differentiation and integration operation does not applicable for the discrete time signal. So note this point. So these two operation does not satisfy the does not for discrete time signal. And another one is amplitude scaling and time scaling. So the name itself it represented as the amplitude will be scaled in amplitude scaling, the time will be scaled in time scaling. So in the amplitude scaling, y of t is equal to c times of x of t. So the amplitude will be scaled by the constant of c. It is amplitude scaling. In time scaling, y of t is equal to x of at. That is, t will be scaled by a factor of a. So these do the main difference of amplitude scaling and time scaling. In time scaling, t is the time. So t will be the scaling by the factor of a. In amplitude scaling, x of t, the whole signal will be scaling by the factor of c. So these two the important difference in amplitude scaling and time scaling. And the next important operation of time shifting operation. See, in time shifting operation we have the two conditions. One is right shift operation and another one is left shift operation. So when we have to perform the right shift, the t0 value is greater than 0 means we have to perform the right shift operation. The t0 value is less than 0 means we have to perform the left shift operation. So y of t equal to x of t minus t0. So this is the basic representation in shifting operation. Right? Okay. Okay students, hope all are you understand well. So see you in next class. Thank you.